I did so also 7 years ago. I did a talk on this, trying to place the different contexts on a timeline and seeing that what's actually going on and how the moving parts are and how they relate to each other. So my goal back then was to try to map it to history and see how it affected each other and how it comes to be the way it was back then in 2016, I guess. So, and I also try to argue that this tech fatigue concept, it's a lot of churn and a lot of changes, actually comes from that in the JavaScript land, all of the explorations and iterations and changes to API and to technology is always historically happened in a user land. So in .NET context, for many years you had this closed source ecosystem that had some sort of a release log every now and then and again. But in JavaScript land and in front-end world, this was entirely different because every innovation happens more or less in the open in user land. So it's kind of changed the dynamic. So the conclusions and the technologies that are the outcomes of those iterations is comparatively what you'll see from other proprietarian libraries and ecosystems. But in front-end, this was happening in user land. So the point I was trying to make was that you don't have to follow on all these. But I think this is about to change, and I think it has changed for the most. So I will argue that now, in later year, even now, 10 years later, or 7 years later, I was talking about React then, and we can talk about React now. So 10 years is a long time. But in the 6 or 7 years that's passed now, there hasn't been a lot of talk about tech fatigue, even though it's been just as much exploration, just as much iterations, just as much many different implementations there's been. But it hasn't felt like such a churn, and I suspect that it wouldn't, from this point on, either feel like such a churn. So I'll talk in this presentation just some about that. So this is an interesting picture still, because not much has changed in reality, like broad picture stuff, since that presentation 7 years ago. If we're drawing the timeline further out, it's still React that's the most dominant, or any sort of library that's abstraction-wise, architectural-wise, the same. So, of course, there are other as well, but here I'm thinking about the overall architecture and the thought patterns that we use in making applications. And in a sense, that's still the same. So it seems like in 2013, when Pete Hunt did a presentation on JSConf in Europe, I think, he was having a talk that went something like rethinking best practices or something like that. And it turns out, in my sense at least, that now we see 10 years later that same thought pattern, the same architecture is still applied, and almost every other libraries and frameworks are still using that same thought patterns with some sort of variations, of course. And think about this. This is actually kind of major because React and component libraries such as React feels like a new thing. But in fact, we have lived longer with React than we have with jQuery before React got there. But in contrast, jQuery felt like an age or a full-grown person age, because it's had such a profound impact in how we did applications, and it's changed the way we're thinking about it. In the same way that React started and did that tectonic change in architectural thought patterns in 2013. So, and what's interesting as well is that all the libraries in the same sphere and in the same landscape with the same architectural patterns, it feels like they get a lot of they get criticized a lot for having changed their APIs and having changed in exploration. I think this is the same thing we saw previously, that we get to see a more open iteration and more open exploration of APIs and patterns, so it feels like a lot. But in fact, you can write almost the same way of React today as you could in 2014. You can take the code from 2014 and run it in the modern day React. And think about that, it's like, for more than jQuery existed before this change, we can still have the same code. And that's, it's a major feat in web development. But it also means that there hasn't been any large paradigm shifts since then. So there have been a lot of different implementations and good ones that change variations of how we do it. But there's a difference between developer experience and paradigm shifts, where the former change how you work, but the latter change how you think. And I argue that since 2013, there hasn't been a major shift in how we think about producing software and producing web applications since then. So even though there's a lot of different frameworks and libraries that change how we work, there hasn't been any that change how we think. In 2006, Gmail launched their single-page application on phones. And that sparked like the dawn of the single-page applications in my book. So since then, everyone identified that everything we distributed through the web should be an application. And everything we distribute through the web should be a single-page application. So that's the tool and that's the hammer we used. And everything was a single-page application. Intranets were single-page applications. Every internet had like functions and comments and social media aspects of it. And of course, as a single-page application, at least during those years up from the 2010s. So around, my figuring is around 2015, I guess, we're beginning to think, okay, let's realize not everything is a single-page application. So if it's not a single-page application, it has to be a static page. So from that moment on, everything was trying to be static site generated sites. We had some static site generation before this, but this is when it was started to, and the technology was so that it was possible to use it as a general purpose application thing. But then we had some issues with dynamic data and started experimenting with how to do dynamic while doing static. And that's an important thing, I think, when we see to the future in what's the next generation architectural pattern there. So the truth is, of course, apps are both dynamic and they are static, and they're everything in between. So there's no problem created equally, and there are wildly different solutions to the different problems. We often forget to address what kind of solution we're trying to make. So we're trying to treat everything like a single-page application or everything like static sites. Today we use terms like CSR instead and SSG. These are just acronyms. It's not important to be there. I mostly included it so that there wasn't anyone like, oh, but you forgot about incremental static regeneration and whatnot, and that's not the different parts of SSG. I didn't forget it, but it's too complex and too much. But also, it hasn't changed necessarily how we're approaching building applications. It's a step towards that, but it's a part between. If we're looking at the specter from totally dynamic pages in single-page applications over to the total static site generation. So it's a specter, and it's somewhere along those lines. So, but again, I don't think these has dramatically changed how we approach writing software. It has improved some of the developer experience. It has improves some of the ways we're working. There are a lot of tools that help us do better products and compensate for the lack of support from the different outer rims of the spectre. But this, I think, is also applicable to think about it in product management or product development terms. So there's a fairly common model in product development that's double diamond model. That's all about converging and diverging in exploration. And I think what we're seeing again is continuous divergent in the technology and kind of a lack of convergence. Because when everything is optional and everything is selectable, so you can select what you want from the different parts, it's hard to converge to a common platform. But I think this is what we're seeing, lack of divergence, but we see a lot of convergence. But again, I think this is about to change. And I think it's about to change because of three aspects. The meta frameworks, and I'll explain all of these and go into the detail afterwards. But the meta frameworks I think that's the main reason why we're seeing more convergence, because we're getting more opinionated stuff that allows us to enforce more convergence. And we'll look at the server-client relationship that's possible due to that convergence. And then we'll see some more about data loading and ownership of data and state as a consequence of the relationship of server and clients. And we'll look into this with the three important W's: what, why, and how. So, meta frameworks. What even is it? This is a term I've heard, I guess, for a year now. It's kind of silly, because what is a meta framework and how is it not a framework? Spoiler, it's a framework. But I think we're slowly painting ourselves in a corner in the front-end world where we've been calling what was actually kind of libraries, calling them frameworks, and suddenly we're getting frameworks that manages those frameworks, and we have no way of calling them or finding a new term for them. So it's just automatically, instead of frameworks, it's meta frameworks, I guess. But essentially, it's just frameworks. It's just baggage for poor naming from before. And I think this is more clear if you see on some of the examples here. So on the left-hand side is what's kind of libraries, but also frameworks. And then on the right-hand side, it's the meta frameworks as complementary to those. So React, for instance, has Next. It has Remix. Things like Svelte has SvelteKit, Qwik City. You have other things like Astro, which is multi-libraries integrated, so you can do Alpine, Solid, React, Astro, Lit, whatever, and bake that down to a common meta framework. And this is kind of interesting because it tightens the relationship and gets more opinionated. And we'll see an example of that soon. But I think a really good study case for this is the relationship between React and Next. Because in this world, we also have to see what's the custodianship, what's the owners and what's the maintainers of those technologies. So here it's natural also to talk about Meta and Vercel. And so it's not a loosely coupled thing, because it's beginning to be some sort of symbiosis between those technologies and between those teams. And we can see that, first of all, Vercel has hired some of the core maintainers from React. And also you see employees for Meta, for instance, referring to them as colleagues, which is a term I think is not used at random. I think it's very, very, like, they're starting to build some sort of collaboration culture between both Meta and Vercel. And that means that not only is the Meta framework taking the framework itself and doing something with it, but it's a tightly coupled collaboration which can create newer things. So when looking back at this, what's the advantages of that? So you can do exploration in a much broader sense than before. You can do a lot more things because you do more. You have the choice of changing more on the meta framework. And when you're doing collaboration between the framework itself and the meta framework, you can achieve even more. So you get more of alignment, more of opinions, which was considered bad in the front-end world. We were proud of having flexibility and having the power of choice. We can do whatever we want in front of me. If state management doesn't suit you, do something else. And we still kind of have that. But I think there's a scale between flexibility and opinions and opinionated frameworks. So there's kind of a trade-off. But I also think that opinions here and opinionated frameworks allow for enforcing a paradigm shift quicker and more clearly than ever before. So the rise of meta frameworks, I think, have incubated this what I think is a tectonic shift in how we think about architecture. So one example of this is the relationship between the server and the client. Again, we saw that over the years, we've done many different ways of doing applications, from SPAs to SSGs and whatever. Behind this is some sort of pull match between server and the client, and how we view as the main source of truth, and how we view it as a state machine or whatever. So let's just start at the beginning and see at the jQuery model. So back in just after the DHTML time, this is how we used to roll out dynamic applications in Web 2.0. So you send over some HTML from the server through HTTP, most likely from servers like .NET or whatever, or PHP even. And you do over the server, and then you look at the server point, select specific nodes, and make those specific nodes dynamic. If they're changing, you're changing only that node and ignore the rest of the page. This is the traditional jQuery model. So when we're transitioning over to single-page applications, or what we now usually call client-side rendering, this is kind of different. We're just sending a blank page, sending that over the wire, and build the application on the client side. So the client side has now total control of what your application is. And if you're doing changes there, the changes happen on the client side, and essentially it happens for the entire page. There are some technologies that mitigate this, but in theory and in practice, it changes the entire page every time. This is also another drawback of this, is that when you're having the source of truth and the original state in the client, you'll have to do a lot of communication with the external. And that's the magical threshold of HTTP. So over there, even though we have local servers and local whatever, there is an overhead. And especially with systems that are like 1 plus O of n commands, like firstly fetch this, and for every element of this, do this. So again, we can mitigate that with things like GraphQL, BFFs, servers, whatever. But in any case, you'll have to do a lot more information gathering from the client over to the server. This is error-prone, this is slower, and there has a lot of drawbacks. There are some advantages as well, of course, but there are also drawbacks. So, given those drawbacks, there have been a lot of server-side rendering focus. So instead of doing server-side rendering, client-side rendering exclusively, you do hydration. So you're sending the initial page from before and then hydrate on the client side, and essentially from there on out, it's the same. So if you're changing something in that, you're changing the entire page, And again, if you're doing a lot of communication with servers and whatnot, you're doing a lot of overhead. It's the same from the point on after the client has received the information, there is still the same drawbacks as client-side rendering. But what we get is more robust. We get search engine optimizations. We get easier support for accessibility. So there are advantages of doing this, but still there are a lot of disadvantages. So a more perhaps newer term is island architecture and partial hydration. Again, it's a couple of years old, but it's still fairly new in thought pattern wise. But instead of sending over and hydrating the entire application again on the client side, you're just marking specific points from your server and saying this is the dynamic one. Everything else is static. Ignore that. And in this case, you only change the specific item that you have marked for this. And it also means that you can send less information from the server to the client because you're explicitly marking something as this is what I want to be dynamic. We also have something else that's resumability. It's a bit newer again and maybe not as known, but it's still used fairly widely in some circles. So instead of doing the partial hydration automatically on the client side, we're sending over static sites and marking that this, when we're interacting with this, and if something happens, like an event, then we're initiating the dynamicness. Again, this is very like a high-level walkthrough, but we'll look into how this is in practice soon. So if we're doing changes here, when we're interacting, only those components and only those nodes in the DOM tree is changed. Well, let's back to partial hydration first, because this is the start of the tectonic shift, I think. So if we're looking at this isn't far off from how I described the jQuery model from. So instead of having the client as the source of truth and the original data and the state management, we're moving that to the server. This has a huge advantage. That's instead of crossing the magical threshold of HTTP, we're doing the entire application fetching from different servers closer to the server itself. So we're reducing risks. We're increasing ability to mitigate errors, so it's more resilient. And it can be cached in different ways across different users. So there has a lot of advantages in doing this. And we're changing so that not everything is on the client, but only what actually needs to be on the client. So there are a couple of implementations of this with different semantics and different ways of doing it. But I think in essence, the change in thought pattern is the same. So it's a shift from a client-first perspective to a server-first perspective. And that changes the entire way your mental model works in how you write applications. So it's not a developer experience thing, it's a paradigm shift thing. So here's an example in Next.js. So Next.js, since 13.4, I guess, has defaulted to, instead of using client-side first thinking, to server-side first thinking, meaning that every component you write, unless otherwise specified, is a server-side thing. This is a pragma key over here with the use client on the right-hand side. It's not important, the details here, but it's kind of important to see that it's changed how we structure and how we think about it. Because, again, when it's server-side first, it means that what happens to secrets, what happens to database connections, what happens to whatever interaction with file systems or whatever, everything of that is hidden away from the client. But explicitly, where it says this is a client side, this will be transferred over. So it's a cleaner separation between where the contexts are, in what context is thing running. And also it's interesting to see that this actually works by having, you can have children of client-side things that are server-side things. It's kind of abstract, but essentially it just means that when opening a server page from this, it starts streaming from the nodes from top down. So when meeting a client-side component, it can have server-side as a children, not as a property, but as a child, because it's streamed as text input and serialized as a JSON structure. So this is an example of output in the browser when running in a simple example like I showed before. And again, it serializes the HTML structure as JSON, and then outputs that specific part of what is dynamic as dynamic. The other parts is just static HTML and has no code other than what's outputted from the server as HTML. Another fine example, I think, is Astro. So Astro is mainly a meta framework for doing static sites, but it's also kind of coined or kind of popularized the term island architecture, which is the same as partial hydration as I've shown in XJS in essence. But there is it's a bit different in how you use it. In Astro you have directives, and you have the separation between what is run on the server and what is run on the client. So what is in the front matter syntax here, as it's probably seen in things like Markdown, that's the threshold for HTTP in a way. So what is inside the front matter happens on the server. It's just code behind, if you will. And you can access that from the code below, which is outputted to the server, to the client. Again, everything you write in Astro, for instance, and here we can use React components and Svelte components, as I said before, and Astro components as its own markup language. But everything by default is server stuff. You have to explicitly mark with the directive things like this, client load. And that says this particular case is dynamic. So only send code and client-side code that's relevant for this component. Everything else, static, ignore it. But this one, this is dynamic. There are other directives as well. Things like lazy or in view, which is treat this as static, but if it gets scrolled into view, for instance, then you can load the data. So if I think the prime example is a carousel that's further down on your page that requires a lot of JavaScript, but only 10% of your users see. Just defer loading of that to the bottom. But again, the most important part here isn't Astro, isn't Next.js, but it's the default thought pattern has changed from thinking, how can we access the server from the client? From that to, okay, we're doing a server here, and some of our output is dynamic. It flips the entire relationship. So by default, just server, just output, just HTML. But some cases can be dynamic, and some cases can be changed on the client side as well. But that's opt-in instead of opt-out in a way. So there are also some safety advantages of this. Like I said, in previous implementations of Next, where you're doing server-side rendering, you can easily leak API keys, for instance, because it relies on tree shaking to clear the data from the different bundles, which means that if you're adding something that's not tree shakeable, it can be outputted to the client. They had some solutions where you can copy paste your code and see what would be tree shaked, but that's very cumbersome and hard to use. But this also means, like I said, when we're changing from thinking client-side first over to server-side first, this also means we're changing and flipping how we're doing loading. So instead of trying to collect all information to the client, we now have more on the server. So this is what I mean about data loading and ownership. So when moving everything to the server, without normal hydration, you have to be dynamic still. We're not just creating static pages. We're still doing and still having requirements of doing things dynamically. But it changes the structure of how you do it. So I think this is the third major change that we'll see a lot more of. And I'll do some examples here as well. So this is from Qwik, which I believe is a framework created by one of the previous Angular people. I don't know. But it's still JSX. It reminds you of things like React, but there are some different ergonomics. But again, it doesn't matter. But Qwik uses resumability. So again, it changes that everything is static unless otherwise told so. But it does so in a different way. So I'll show an example of this. Given that we have this counter, which is the classic example, I guess, we get this output. So plus, increment, a decrement, and a number. This doesn't do anything. It's just HTML. It just outputs HTML, no JavaScript whatsoever, with a few changes in the caveats. But for point being, it's mostly HTML. But look at this. So the button itself has a reference to it. And it has odd hashing or something that seems oddly specific. So we can reduce the example of this to this. Just ignore the fact that I've written href here instead of button click, but it's the same principle. So given that you have an HTML output, they also include a global event listener that listens to every click you ever do on the web page. And when you're doing a click, it tries to match and see, is this something that I want to handle? So when clicking on that button, it goes over and importing using ESM modules and importing that specific file as referenced and that specific function that is exported. So in this example, we can see that for the first increment, that refers to a specific export in that module that is dynamically loaded when clicking on it. So this is an example of it running. So we're seeing that when loading the page, there isn't any JavaScript. It's embedded in the page. But when clicking on it, you get the function itself. But also, you can ask then, doesn't this go against the principle I just said of reducing the number of calls? This will maximize the latency. So every time you increase, every time you click on something that's interactable, you're downloading a small chunk of something. That's incredibly wasteful for latency and overhead, and especially if you're not using things like CDNs and having servers close to your client. But the way they mitigate it is by using service workers. So preemptively for every page you're opening, they're caching essentially the every interactual element in there. So if you see here, it's loaded from service worker instead of actually downloaded. So they're kind of mitigating that instead. So the initial load will still load some code, but it's when revisiting the site, for instance, it's not as bad. But this is an example of something Qwik calls RPC. And RPC, as we know, is remote procedure call, and it's existed for generations of developers. So it's just the fact that giving some sort of invocation or command at some sort of service, I'm trying remotely to trigger that and get the result. Of course, in Qwik world, this is just HTTP. But again, HTTP is some sort of RPC. You're executing a specific command on a server and getting the results. So this isn't a fancy new protocol or some specific thing. It's just an import statement referencing a specific type of URL that Qwik has constructed. So in this Qwik example, we're still dynamic. The RPC is more how to load code and not state. And we're in this way, we're still having the state and the source of truth in the client side, not on the server side. But this is an example of how we can change how data loading is. We can see another example of that using server actions in Next. This was launched as alpha for a month ago, I guess, for Next.js. So it's in alpha in Next.js 13.4. Again, what I want you to take out of this is the switch between who owns the state and switch between who owns the data. So this is obviously a ludicrous code and not something that's recommended, but it shows that if we're doing state on the server, we can expose that and handle that on the server side. We can see the running example after a while to see how it works, but if we're seeing here, the output is just HTML with a button. And when trying to click the button, if we're adding a breakpoint for the XHR, we can see that when doing a button click, it just actually does fetch underneath to itself in the same at the same URL with something called next action with an action ID there. So this action ID, as sent to a header, is the same as seen in the HTML itself. And in fact, we can see that this is just a form with specific IDs on each button. So when clicking the different buttons, we can see that it works. But even though, and we can even disable JavaScript, and it will still work as same intended, because the way the RPC here works is they identify what is marked with the pragma key as userver, extract that as a separate endpoint in the same file, essentially. So instead of being a GET request, it's a POST request, as I think forms only support GET and POST, maybe others as well, but yeah. So then when doing a POST request through the form to the site itself, with the header information or with the form information of the button with a name, they can map it to a specific action on the server side. So this is maybe a more an other example of RPC, but it's still a packed RPC. And we can do server loading with this as well, instead of just doing it through a form, but we can get server information where it then extracts as its separate API, a separate endpoint, and then do a POST request or a GET request from that endpoint. But in the code, it seems like just a function call. This is major in a way, because this means that interactions with data and state is progressive enhancement proof by default. Because here I didn't write any specific code for handling data here on the server side or the client side. It just works without JavaScript. And there's not much point per se to absolutely not support JavaScript. There isn't many turning off their JavaScript, but it also means that if something fails, it can degrade to a lower form of working. So we're building in complexity instead of going complexity first. This is of course not without its caveats. So one major drawback is obviously that there's a lot more distance from what we're writing to what we're observing in the client side. So before, we're just doing bundling of sites, and we're having source maps to match from the bundle over to the actual source code. When there's extractions and creating different API points that we don't see and it's abstracted away from us, there's a larger distance. So it might make it harder to debug. But the advantages are it's closer to real semantic coupling and coupling of data. So complexity cannot be created or destroyed, only transformed from one form to another. Obviously not true. I create complexity every day. But also not true. Because I think often when we're trying to introduce architecture to reduce complexity, we're not really reducing complexity, we're just shuffling complexity around. And I think this is true for this case as well. Because before we had the major drawback of server-client relationship and server loading before was that things that are supposed to be semantically coupled are architecturally loosely coupled. So we're trying to mental model our way around loading data. But now with this, we're changing that around to being things that are semantically coupled are actually technically loosely coupled because it's degrees of different separations of how we're interacting with them from protocol to protocol, etc. But again, it doesn't reduce complexity. It's just a different type of complexity, and I think it's a matter of finding the complexities and abstractions you can live with. So I think those three major building blocks now will change not only how we work, but how we think about building web applications. So it will make a much larger dent in how we think about it, not only how we work with it. So meta frameworks are more opinionated, causing it to be able to converge more and enforce opinions a lot more. It means that we can see larger changes, but I think maybe it will lead to lower churn as well because we won't see the entire exploration and iteration phase. And we see that the meta frameworks uses their opportunity to do so, and they use their power to enforce their opinions as intended. Before, I think front-end developers was mostly against having two opinionated things. I think maybe that's about to change. And also think that seeing how they're changing things and flipping the relationship in server and client to being server first instead of client first, it means that we need new ways to interact with data. We need new ways to do state management. We need new ways to load data. And it changes who retains the ownership of that data. So again, it isn't without trade-offs. But the advantages you get is lower time to interaction, less transfer data. We get more robust solutions. And last but not least, we get progressive enhancement by default, something that's been lacking for many solutions for the last 7 years. So one important part of this paradigm shift, I think, is it moves kind of the way we're able to evolve systems over time, because it's a lot easier to move to more abstractions and more tooling than it is to move to less. So for instance, moving and going from a fully fledged single page application over to a server-side rendered progressive enhanced solutions or a subpart of a solution is really, really hard. Moving from just server-generated stuff over to a more dynamic subpart is much easier because it's from a lower degree of abstractions to a higher degree. So I think the movement here to being server first will be a big part of the next generation of the server and the way we think about creating web applications. So it's more than just server-side rendering, and it's more than just data, but I think it's building blocks building on each other to converge a lot more than before. Also, I think it's getting more polarized in a way in what we're creating, because we will still see these single-page applications. We will still see the static site-generated content, but I think it's more important than ever to think about the advice we get and see if is this applicable to my problem area, and is this applicable to me? And I think we're probably moving into a time that we'll see more and more transition into server-first thinking, but it will probably take a time before it does so. That's it. Questions, comments to Twitter. Also, I have 2 Norwegian podcasts in strange dialects. So I mentioned all that so in hope for getting listeners. I think kortslutning, see that, and send me a message if there's any comments. Other than that, I'm done.